Hello everyone. In this video we will show you how to create, edit, and develop Sigma Studio programs for the Mini-SAM player. So to start off, let's begin by showing the setup here. I have a PC hooked up through Ethernet. In this case I'm actually hooking it up directly through a crossover cable to the Mini-SAM. So our Mini-SAM is this section right here, Mini-SAM, and on the PC I have Sigma Studio running. Sigma Studio is a free application that was developed by Analog Devices, and you can go to their website here, and this is the website where they have, and it's a free download. You can download Sigma Studio and use it to your heart's content. And so in our configuration here, we also have a console port connected up through serial. And that port is running at 115/200 baud. So inside the Mini-SAM, we have our main processor unit, and that processor unit talks to our digital signal processor that handles all the audio over an I2S bus, and it generates out the analog audio to the amplifiers and then eventually to the audio outputs. What this demonstration will show is how to enable that pass and to allow Sigma Studio to directly control the signal processor on the fly, and we'll do it while we're playing audio so we can audibly hear the results of our Sigma Studio setup. So to get started with, let's go ahead and let's try and establish a connection. And to do this, the first thing you need to do is determine the IP address of your computer. And there's many ways to do that. Probably the most common way is to go to your command prompt and just type in ipconfig. Let me do that again. There we go. And if you look through the configuration setup, we can see that our link here is set up through our Ethernet adapter, and the address of our computer is 169.254.144.100. There are other ways to determine this, and I'll show you a couple other ways. Another way is to open up Hercules. Hercules is a free download developed by the hardware group. I'll open that up and run it. And here you can see the same result. This is the IP address of your PC is 169.254.144.100. A third way to determine this is you can open up the programmer application. That's an application written by SKE. And when you open the application up, it tells you here at the bottom that what your IP address is. Another way to tell, another thing you need to do is to make sure your Mini-SAM is within the same IP subnet group. And to do this, I'm going to go ahead and open up a console application. You can use any console application. This is one that was written by SKE, and it allows you to establish a connection and then view the contents over that command or through that console port. So what I'm going to do is go ahead and start up the Mini-SAM, and when I do that, we'll get the boot screen. And from the boot screen we can see that our IP address right here is within the constraints of the PC. So our PC was 169.254.144.100, and this Mini-SAM is set to 60. Also, you should note here that our Sigma TC port, which is the server that handles the Sigma communications, is set to 8086. This is something that we need to keep track of. If it's not set to 8086, then we need to change that on the Mini-SAM so that it is, or change the port defined within Sigma Studio. But right now we have our Mini-SAM open, and first thing I'm going to do on the Mini-SAM is to turn verbose on. And what this does is it allows us to get a little more detail in the commands that we see typed in through the console port to the Mini-SAM. But more importantly, what it will do is it gives you real feedback of the TCP connection made through Sigma port when you're sending data to it and receiving it. It'll print out right on the screen, and it's handy to see that you have a valid connection that way. Okay, next let's go ahead and open up Sigma Studio. And again, if you don't have Sigma Studio, you can get it at the Analog Devices website. And there are a couple other things you need to make sure you have, and I'll show those to you right now. Right now I'm looking at the Sigma Studio folder inside of program files, and there are a couple files you need to have installed that you can get on the SKE website. One is this compiler folder right here, and this provides some add-ons to Sigma Studio that allow it to talk to the SKE devices. And there's also another DLL called TCP/IP DLL that has the application extensions for the SKE products, again, to talk to Sigma Studio directly. So those two things need to be installed right inside the main Sigma Studio folder, and again, you can get those at the SKE website. So let's continue on now. Okay, to start off, I'm gonna go ahead and create a Sigma Studio application from scratch. So I'm gonna go ahead and open up Sigma Studio. And then one thing I'm also going to do is I'm going to go ahead and enable the server on the Mini-SAM. So the command for enabling the server is sigma on. When you see that, you can see that the TCP IP server socket is opened. Okay, so next we're started off with a blank workspace. And there are two things that you need in order to establish a Sigma Studio connection. So let's go ahead, start off with a new project here. And for this brand new project, the two things we need is a communication channel and a processor. So the communication channel that you will use with the SKE products are either the 1953 channel, or you can use the 1701. The 1701 channel is used on the RPod for the input processing Sigma processor, and then the 1953 is used for the audio codecs that are both on the Mini-SAM and the RPod. So I'm going to go ahead and drag out onto the screen a communication channel. And then also we need a processor. Well, the only processor on the Mini-SAM that we need is a 1953 processor, as shown in that original block diagram. Let me bring that up again. Right there, 1953. So I'll drag out a 1953 processor. Okay, you'll notice on this TCP/IP communication channel, there's allocations for 4 spots. And those 4 spots would allow this communication channel to talk to an RPod. That our RPods have 4 1953 devices. But on a Mini-SAM, there's only one, so we're just going to hook up the one. And so I'll connect up that interface. Now we have the channel connected up. And then let's go ahead and check our TCP connection. So I'm going to right-click in this small area right here next to the TCP/IP text, and I'm going to go ahead and show our TCP/IP port. Well, we can see right away that with our IP address is wrong. What we really want is this IP address right here, the 169.254.144.60. So I'll go ahead and copy that over here and paste it in to our IP address, and then I'm going to go ahead and attempt to open the communications channel. And we can see here that our client was connected. So now we have a valid connection between Sigma Studio and our Mini-SAM. So a couple things to note here before we get to the schematic portion of this is to look at the hardware configuration controls. Now these can be tailored, but in general you want to use these setup conditions. We're going to not implement a de-emphasis filter. In this case, we're going to be using I2S 24-bit audio, and our clock mode will always be set to 512 times the fundamental frequency. And in the case of our Mini-SAM, we connect up our devices through mClock0, so they should be set to mClock0. Those are the only things you need to set up on the input processor. Okay, next we're going to go ahead and set up a schematic. There are only a few things that you absolutely have to have, and the first thing you need is an input. So I'm going to come down here to the IC section to I/O, and I'm going to go ahead and drag out an input. And so for our 1953, there are 4 possible inputs that you can have. In our case, we only have 2. We're going to use 0 and 1, where 0 is the left and 1 is the right. And then we need outputs. For outputs, we have 3 possibilities. We have left. I'm going to go ahead and change that to left. We have right. This will come out to be right. And if you want a subwoofer, you can have a subwoofer too. So I'm going to drag up the subwoofer here, and that's our sub. So those are the inputs and outputs. And then the other thing we need to have internal to that is a volume control. And I'm going to select multiple volume control device here. Drag it out. When you drag it out initially, you're only going to get 1 volume control. Well, we want to extend that to make it 3. So I'm going to right click and go to cell settings. Add algorithm. And I'm going to go ahead and add another gain stage for the right channel, and then add a 3rd one for the subwoofer. So now I have 3 volume controls. Move that over here. Now, on the 1953, the subwoofer, since there are only 2 inputs and there are 3 outputs, the subwoofer has to be derived. And so in order to derive that 3rd channel, we need to take that off of the left and right. So what I'm going to do is start off by adding a mixer here. Now, in the simplest form, we could just simply add a signal mixer. And I'll go ahead and do that to start off with. And what this signal mixer will allow us to do is take both the left and right channels and combine them into one signal. Another thing we need to do to implement that is to put a T connection in. That allows us to do the original split. So I have 2 of those, and I'll connect these to our left and right inputs. And then this will go to this left one, and this one will go to here. And then we'll add our split connections here. And then this becomes our subwoofer channel. Okay, now when the Mini-SAM initially powers up, this is the configuration that's set up. It's simply a pass-through with a 0 gain, and everything passes from the input to the output unprocessed. And that's what this configuration would show. And so we can actually hook this up. And let me go ahead and do a link compile and download. Okay, now what you'll see happens is that when I do that link compile download in the terminal program, we're going to see the data actually being transferred to the Mini-SAM right here. This is the download. And then anytime, I'll go ahead and clear the screen here. Anytime I make adjustments now to this compiled design, like let's say for example I change the volume, is those commands that go out to the Mini-SAM will be illustrated on the screen and fed back. This is the actual data being sent to the Mini-SAM to change that volume. And we can see this. I have a Mini-SAM hooked up with a speaker attached to the left channel, so we can do this. I can go ahead and play a sound. We can hear the sound there. And then as I adjust the volume control, you can see that volume control adjusts on the Mini-SAM itself. Go ahead and stop that. Okay, this is a really simple application setup. If we want to add some more complication to it, then we can add things to the circuit, like we can add an active EQ. So what I'll do here is let's go ahead and delete these connections here. And I'm going to go ahead and insert some filters. So let's go to the filter section. And if we want to, we can just take here and we'll stick a general filter here. Let's go ahead and stick another one here. And then one for our subwoofer. So I'll move this over down out to here. Give them some space. And I'll hook up the left filter, the right filter here. And then I'll hook up a sub. So for the sub, we typically going to have a low pass filter. So I'm going to go ahead here and select general low pass filter. We'll set the frequency down at say 100 Hertz. And we'll leave the key there at 1.41. For these, I'm going to go ahead and put a high pass filter in. Again, setting that at 100. Do the same for this guy. And we'll connect it up again. After you make changes to the schematic, you need to go ahead and perform a link compile download. And again, it compiles the program and then downloads it into the Mini-SAM. And now again, we can go ahead and play again. We have control of it. If we want, we can change these parameters on the fly. So if I wanted to change that to a 3K filter, you can hear that most of the signal now is being cut out. And I'll readjust that back down to 100. can see you can make these changes on the fly. Go ahead and stop that. Okay. Next thing I'm going to do is I'm going to put some processing after the volume control. In this case, I'm going to go ahead and put some an EQ set up here. So what I will create here is let's go ahead and remove this algorithm, and I'm going to go ahead and add a double EQ here. In this case, I'm gonna allow for the left and the right to be processed through this, and then we want to grow the algorithm here, and let's make this a 4-channel EQ as such. Move these out. I'm going to take the subwoofer channel and just send it directly from the output, and then connect the left up to the top here and the right up to the bottom, and then connect it to the outputs. And then we can set the frequency. So if I want, say, this first one to be at 200 hertz, I'll leave the second one at 1K, or maybe let's make this 500. I'll make that, leave that at 1K. We'll make this 2K and 4K. Again, I'll link, compile, and download. You can see our new designs going into the Mini-SAM. And now I can go ahead and play that and adjust the parameters. So again, if I bring the low ends down here, make it all flat. We want this to be 4K. So if I raise the high end, you can hear the high end of the sound there increases. Okay, and so you can add any of the components you want from this list into the design, and you can compile it and see if it fits and then make adjustments to it. Now, once you have this set up the way you want it to, and configured the way you like it, you can simply come over to the console terminal and say sigma save 1. And what that will do is, if I look in the directory here, it will create files on the compact flash disk. It'll create this file here, setup Sigma C1 and prog C1.hex. These are the two configuration files now. This configuration now is loaded onto that Mini-SAM, and whenever the Mini-SAM powers up, it will automatically load this setup right here into the unit, and this is the program it'll run each and every time. That concludes this demo of setting up Sigma Studio. Thanks very much.